Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of Linux Interprocess Communication, or IPC, a topic that's both incredibly useful and, let's be honest, a bit mind-bending.
Mind-bending is one way to put it. So what are the main ways processes on Linux can chat with each other? I'm picturing tiny little programs whispering secrets.
Exactly. And those whispers can take many forms. This GitHub repo we're looking at showcases several methods. We have file locking, which is like a bouncer at a club, making sure only one process can modify a file at a time. Then there are pipes. Think of them as straws for data. Unidirectional, simple, perfect for parent-child communication.
Straws, I like that analogy. But what if we need something more robust, something that can handle communication between unrelated processes?
That's where named pipes, or FIFOs, come in. They're like designated meeting points, with a name in the file system, allowing any process to join the conversation. It's like a public forum, but for processes. And then we get into the more sophisticated stuff. Signals, semaphores, message queues, shared memory, and sockets.
Whoa, hold on a second. Signals. Are those like urgent interruptions, a process yelling, hey, something happened?
Precisely. Think SIGINT, S-I-G-K-I-L-L, SIGIL-RM. Those are the emergency broadcasts of the process world. Semaphores, on the other hand, are more like traffic lights, controlling access to shared resources and preventing chaos. Message queues are like orderly lines at a post office, ensuring messages are delivered in the right order.
I see. So shared memory is the fastest, right? It's like having a shared whiteboard, but for processes?
Exactly. Shared memory is blazing fast because there's no data copying involved. But it needs careful synchronization to avoid a complete data meltdown. Think of it like a really fast, but potentially very messy, whiteboard. You need to be careful who's writing on it at the same time.
And sockets? Aren't those for network communication?
They are, but in this context, we're focusing on Unix sockets, which are surprisingly useful for IPC within a single machine. They provide a powerful, flexible way for processes to communicate, even without the overhead of a full network connection. It's like having a private phone line between processes.
This is all incredibly detailed. I'm particularly interested in the code examples provided for each method. They seem really well structured and easy to follow, even for someone who's not an expert in Linux system programming. I wonder if there's a way to combine some of these methods for even more complex communication scenarios?
That's a great point. Absolutely. Many real-world applications use a combination of these techniques. For instance, you might use shared memory for high-speed data transfer and semaphores to manage access to that shared memory, while using signals for asynchronous notifications. It's all about choosing the right tool for the job. The beauty of this repo is that it provides a clear, concise example of each method, making it easy to understand and adapt for various scenarios.
Definitely. This is a fantastic resource for anyone wanting to delve into the intricacies of Linux IPC. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time with more exciting explorations of the tech world. Bye.
Bye-bye.